There are two types, maximum grades and the minimum grades. The value for maximum grades vary internationally, with some or all of the following factors being considered: road type, design speed, terrain, and vehicle classification. The maximum grades that could be used in the urban environment varies from 4% up to 10%. If some of you travel across the Punt Road Hill, okay, you can imagine a very steep grade, and that grade is about 11%. Grades steeper than shown on my slide may be justified in certain circumstances. For example, steep grades offer a comparatively short section may lead to significant cost savings. May be necessary to link existing points with vertical control levels, and may be acceptable where heavy vehicles numbers are low. The following additional factors must also be considered to achieve a safe environment for all roads users. The road grade may have an impact on the grade of abutting footpaths, cycle paths, and shared paths. It may be more appropriate in terms of overall cost and amenity to limit the road grade to the maximum required for cycling or disabled provision. Where a grade steeper than the maximum value for normal situation is used, horizontal curves immediately following the downgrade should have a design speed 15 kilometers greater than the design speed applicable to that section of road. And at the intersection, including long queue lengths, bus stops, and median crossings, the grade should desirably not exceed 3%, with a 4% being absolute maximum. The designer should consider the resultant crossfall generated by the combination of the longitudinal grade and road crossfall, particularly in the turning pass areas. The minimum grades should vary from 0.3 to 1%. They are usually fixed by drainage considerations. Generally, for major urban roads, when curb and channels or other form of lined or paved drain is used, a desirable minimum grade is a 1%. An absolute minimum grade is a 0.3%. Is recommended to drain water effectively from the traffic lane. The removal of water from the road surface is essential to prevent aquaplaning. Vertical curves are normally used to join sections of road with different grades. The purpose of vertical curves is to provide a safe, comfortable transition from one grade to the next. Adequate sight distance across the junction of two grades, and satisfactory appearance. The most commonly used form of vertical curve is a parabola. This form provides a constant rate of change of vertical acceleration for vehicle and is a relatively easy for calculation of setting out points. Most vertical curves can be designed using the following formula, where K is a vertical curve constant used to define the shape of a parabola, and L is algebraic grade change. Okay. The vertical curve constant used to define the shape of a parabola expressed using the formula shown on this slide. Type of vertical curves. 2. Crest and a set. The lengths of crest vertical curve are usually governed by the need to provide stopping side distance or approach side distance at the operating speed. Crest vertical curves are shown on this slide. Seg vertical curves that's shown on this slide are generally considered less critical from a safety perspective than the crest vertical curves. The length used for the seg curve affects the appearance of the road, and in the case of short seg curve, it can affect the comfort of the ride. In geometric design of major urban roads, it's quite vitally important to coordinate the horizontal and vertical alignment. Coordination means that the horizontal and vertical curves should either be completely superimposed or completely separated. The related horizontal and vertical elements should be of a similar length within the vertical curve contained within the horizontal curve. This arrangement should produce the most pleasing, flowing, three-dimensional result, which is more likely to be in harmony with the natural landform. However, in urban situations, it is frequently the case that such aesthetic considerations will be very difficult or expensive to apply or to achieve. Many urban roads are developed by widening established streets or by developing improvements on existing alignments. In consequence, the existing street locations and levels and abutting developments will exert a strong influence on the alignment of major urban roads. Notwithstanding, the following relationships between the horizontal and vertical alignments should be applied to the design where possible for safety, aesthetics, and drainage reasons. A crest can obscure the horizontal alignment and the severity of the horizontal curve. Minimum radius horizontal curve should not therefore be used within the crest vertical curves. Crest vertical curves should be contained within the horizontal curves to enhance the appearance of the crest by reducing the three-dimensional rate of change of direction. This also improves safety, but indicating the direction of the curvature before the road is obscured by the crest. The next reason, the design speed of a road in both planes should be the same, this improves drivers' awareness of the speed environment. A small movement in one dimension should not be combined with a large movement in another dimension. Sharp horizontal curves should not be introduced at or near the top of the crest vertical curves. The change in alignment may be very difficult to see at night. Sharp reverse horizontal curves are undesirable in association with a crest vertical curve. The crest can obscure the reverse alignment. A crest vertical curve or a sharp horizontal curve should not occur at or near the intersection or rail crossing. Carriageway narrowing, changes from divided to undivided road, traffic islands, and median noses should not be located at horizontal and vertical curves unless adequate visibility is available to ensure approaching drivers are aware of what is occurring. A short vertical curve on a long horizontal curve and a short grade between the seg and a crest curve will have an unattractive appearance. A long seg curve will provide better visual continuity than a short seg curve. Very long crest and a seg curves, which result in a long section of a flat grade at the top and at the bottom of the curve, should be avoided to ensure that pavement drainage and aquaplaning problems do not occur. Crest and seg curves, in conjunction with a change in superelevation, should be reviewed carefully for adequate drainage. Examples of acceptable and unacceptable coordination of horizontal and vertical geometry shown in the next slides. You can see this is where the ideal combination is. Curves are superimposed. A smooth flowing appearance results when the vertical and horizontal curves coincide. Ideally, horizontal curve should slightly overlap the vertical curve. The next slide is showing the acceptable coordination. If the horizontal scale is large and the vertical scale relatively small, it may be satisfactory to produce two vertical movements on one long horizontal curve. And both examples have visually poor alignments, as you can see, with unrelated horizontal and vertical curves and broken back curves, horizontal curves. And a short movement in one plane should not be placed within a large movement on another plane. You can see it's plane in a plane and in a sort of horizontal alignment and a vertical alignment. You can see the way when they interrelate and how the road will look like. Cross-section elements. This section of cross-section elements for the major urban roads is in iterative process seeking to optimize function, safety, environmental impact, economy, and aesthetics. Cross-section elements are discussed on my next slides. They are traffic lanes, covered channels, shoulders, median, water separators, and urban borders, footpasses and nature strips.